Measuring friction, 10 metrics. In the last few videos, we established friction as a real feature of complex systems. Friction already shapes how fast economies adapt, how safely change happens, and how far optimization can reach. The challenge is not whether friction exists, it's that friction is difficult to measure directly. It's distributed across laws, institutions, infrastructure, and historical decisions, rather than appearing as a single variable. In this episode, we introduce two measurable metrics for each friction factor. These metrics are chosen because they capture important, observable aspects of friction in ways that can be compared across countries, even if they don't capture everything. Privacy metric number 1, personal data availability. The first privacy metric is personal data availability. This metric reflects how much individual-level economic and behavioral data exists in forms that can legally and practically be accessed for analysis. It's evaluated as a snapshot and trend hybrid. The current level captures how much activity is recorded in usable systems today, such as transactions, records, or digital traces, while the longer-term trend shows whether that coverage is expanding or contracting over time. Lower data availability and tightening trends correspond to higher friction. This metric is relevant because it sets a basic constraint on analysis. When economic or social activity isn't captured or accessible in usable form, optimization systems are forced to operate with blind spots, regardless of how advanced they are. Privacy metric number 2, consent and permission overhead. The second privacy metric is consent and permission overhead. This metric reflects the procedural cost of accessing and using data that already exists. It's evaluated as a snapshot and trend hybrid. The current level captures how many approval steps, permissions, compliance checks, or usage constraints must be navigated today, while the longer-term trend shows whether those requirements are becoming more restrictive or more permissive over time. Higher overhead corresponds to higher friction. This metric is relevant because procedural burden directly raises the cost of using information. Even when data is technically available, layers of permission, review, or compliance can slow, limit, or discourage its use, acting as a practical source of friction in real systems. Safety metric number 1, biotech approval cycle length. The first safety metric is biotech approval cycle length. This metric focuses on approval timelines in biotechnology, where AI and automation already have the potential to accelerate discovery and development. It's evaluated as a snapshot and trend hybrid. The snapshot reflects how long biotech approvals usually take today, and the trend shows whether that process is speeding up or slowing down over time. Longer cycles and slowing approvals correspond to higher friction. This metric is relevant because biotech acts as a bellwether. How safety protocols behave in this domain offers an early signal of how approval systems respond when technology begins to move faster than existing regulatory processes. Safety metric number 2, biotech preemptive safety burden. The second safety metric is biotech preemptive safety burden. This metric reflects how much effort, cost, and procedural complexity is required before a new product or modification can be deployed. It's evaluated as a snapshot and trend hybrid. The snapshot captures current requirements, such as documentation volume, validation steps, compliance costs, and reapproval thresholds, while the longer-term trend shows whether these pre-deployment burdens are increasing or easing over time. Higher burden and increasing trends correspond to higher friction. This metric is relevant because biotechnology sits at the center of public safety expectations. How a country chooses to manage risk here, by blocking uncertainty up front or by allowing controlled iteration guided by advanced tools, provides a strong signal of how safety friction is likely to behave as technology accelerates. Digitization metric number 1. Physical-digital integration. The first digitization metric is physical-digital integration. This metric reflects the extent to which the physical economy is connected to digital systems through physical-digital interface technologies like RFID or QR tagging. It's evaluated as a snapshot and trend hybrid. The snapshot captures how much of the physical economy is currently connected to digital tracking or sensing systems, while the longer-term trend shows whether that connection is expanding or stalling over time. Lower integration and slowing trends correspond to higher friction. This metric is relevant because optimization can only act on what is digitally connected. When large portions of the physical economy remain offline or opaque, AI systems are limited in how far they can observe, manage, or improve real-world processes. Digitization metric number 2. Human digital identity adoption. The second digitization metric is human digital identity adoption. This metric measures the share of the population that has at least one verified digital identity used within digital systems. It's evaluated as a snapshot and trend hybrid. The snapshot captures current adoption, measured as the percentage of people enrolled in digital identity systems, while the longer-term trend shows whether adoption is expanding or stalling over time. Lower adoption and slowing trends correspond to higher friction. This metric is relevant because it acts as a leading indicator of social acceptance. When people adopt digital identity, it signals a willingness to accept and trust automated digital processes. When adoption remains low, resistance to broader digitization is likely to persist. In this episode, we introduced measurable signals for privacy, safety, and digitization friction. Next time, we'll complete the framework by examining ownership and government. Thanks for watching.